Now we have intersection of the types. So we create these two types, admin and employee, and both of them have name property in common, and one has privileges and other has start date. Now we want to combine these properties, so we use this AND operator here while creating a new type which uses properties of both of these. So now this name will be common and this type need to have privileges and start date also. So it will have these three properties now. We can create an object based on this condition. We can, for example, here we have a type which uses union, can be string or number, and numeric can be number or boolean. So when we combine these two with AND operator, use the intersection here. So now it will have all three. It can have these three types. You can also use this on interface. Here, when we extend, so we will extend both of the types. This will give the same result. It depends on what we want to use, type or interface. Mhm. In example, we have string or number. We can use both of these. So when we use combinable here in a function, creating a function, we want to add a and b, give combinable type. So now when we just return a plus b, its return type will not be defined. So Typescript will not know what the return type is. So we can use this type of keyword in this. So this is called type card. Type of A string and type of B string. Then return, then convert this to string and add. So this will then return a string. Otherwise, this will return A plus B. It's the numbers. So use this type of keyword to put the condition for both that we can use here, string or number. This is just JavaScript syntax. This is present in JavaScript. Another keyword that we can use is in keyword here. We have employee and admin. Now, for example, we create another type which uses either employee or admin with union unknown employee, and we create a new function here to pass this parameter of type unknown employee. So now we want to see we have employee because both of these have privileges and start date in each one of them. So now we want to access those properties. We can use this in keyword here. If privileges, so the property name in this parameter that we pass. If privilege is present in this, then print that, then we access that and dot privileges. Similarly, if start date is present in this instance, then we get start date. And also we want to print name, which is the common property here. Similar to type of, but type of we can only use when we have JavaScript because number and strings are built-in types in JavaScript. So when we are here creating our own type, Then we can use this in keyword to access the properties that we want to check. And the type that we have is this instance of, that we can use to see if this is an instance of this. Create two new classes here. One has this drive. Both of them have this drive method that we create inside. They both print some different message. Now create another type vehicle which uses this car and truck as union. And then we create two new instances of this car and truck. Create a function. We use the type vehicle, which is union of car and truck, and then we pass this method, drive method. Now we want to see of what class is this the instance of. So for that we can use this. If vehicle is an instance of truck, then print this and get this load cargo. This is another method that we create. Will pass a number amount and then print that with the string and the amount that we pass. So then pass this. This is an instance of a class. So just to see if something is an instance of one class or the other. Now classes, but we cannot use instance of on interfaces because interface we don't create the instance for interface. So in that case, we have this two interfaces that we create type. So here we have flying speed, which is a number type, and on also running speed, which is of number type. We create another type which is union of both. Then we have function pass the parameter of animal type, and here we use this switch and case. So we create a variable here and we switch animal dot type, and this is what we create in both of them. So both have different properties. We want to access them. So for that, first we create a property of same name in both the interfaces and pass a value which is different for both the same name. And then we can use switch to switch to that property from this. So on animal, we will, this is the union, we will have the type property of both. So we switch to animal dot type and then we use case. If case bird, so if this is the value, then get animal dot flying speed and store that in the speed variable. Okay, and then case if force and then use animal dot running speed, which is the property of this. So we can access the property of both the interfaces by defining type the property of same name, and then you console print that the speed that we get from both. We have typecasting. Like for example, on HTML, we have some user input element. Where we have some user input element, we want to use that in our Typescript file. So for that, we create a constant and we use document to get element by ID. So we created the ID user input. We access that here. But now Typescript does not know that, it just knows that this is an HTML element. It understands that by when we write this get element by ID, it understands that this is the DOM property. It does not know what HTML element is this. So we can define that here. So to access that properly, we define that by using this brackets, and inside that we write the type of HTML element that it is. In this case, HTML input element. You can also use this as keyword with document.getElement by ID, and we pass ID, and then as HTML input element we give the type element here. So this is typecasting. Now we can use if statement. So we have this constant if that is present. So to access its value, then we can use that here also inside this if statement to access its value and write the value from here from a Typescript file. Pass the value from here. We give the type again here. Use input element as HTML input element, then we pass the value. This is typecasting. Now we can use index properties. This is we can use when we are not sure how many properties we need to have in our object. So we want that to be flexible. So for example, here we want to create an interface where we catch the errors. So when we have a form in our HTML file, we will take emails, username, etc. So catch errors, messages here, give the message. We can have different properties like email, but not a valid email must start with the character username. So we are not sure how many properties we will have. We can have one of these or both or another property. Then we can use this square bracket, and inside that we give a name and give the type of that name first, name, and then the type of the message that we want to print here. So the type of that property then. So now we can have any number of properties here with our of type string. So we just define this one. Then we can have different names also. So this is how we can be more flexible with our objects that can have different properties. So then we create a constant, we pass the type of error container, and then we write this email and username. These two properties we have to be of string value. We cannot pass a number here. Or we can pass a number here instead of this. This will be valid. Here we have the combinable. We pass A and B and both are combinable type, which can be a string or number. So here we are not sure. We'll turn a string or a number. So then we can define the types here where we use function overloads. So this is how we can use function overloads. We create the function like this, and then we write the same function line and function name, and then we can pass the types. We can define the different types that we have in this combinable. For example, both are number, then it returns number. If both are string, then this returns string. If one is a string, and then also this returns string. So we can define that here with the function itself. And then if they are string, then we can use this is the method that we can use dot split on string, split them on white spaces. So we can only do this if we have both of these as strings, so you can define that like this. Otherwise, we will not be able to perform this function because this does not know what is the return value type here. Now we have optional chaining. So this is to access the nested properties. We have a constant here fetch user data, the ID, name, and job. For example, we get this from some other source like a database or like backend or some other source, and we are not sure about if we have that property, then we can use this question mark. On fetch user data, we see if there is a job property, we use question mark, and then job, on job we have title. And then this double question mark is to see knowledge coalescing. So if this returns null or undefined, for example, we just hard code this here. So user input is undefined in this case. So we want to put the default if this is null or undefined. Otherwise, we want to just get the message. Now we want if we pass an empty string here, this will still pass the result as default. It will treat that as null. So that we can use this to get null and only get default message in case of null or undefined. If there are empty string or zero or whatever something else, then we just want to print whatever string we pass. So this is what we can use. So we have generic types. Generic types are the types that are connected to another type. Like we have an array. So it can be an array of strings or number of or any type of array. Array is a generic type. So this is a built-in generic type here. So we can define that with this method, or we have this another method where we put the string in bracket with array. We define the type of this constant as array. So this is the generic type here. And then we pass the other types that it is arrays connected to that array can have. Otherwise, it will be of type any. Now it is a string of array. Then we can perform the string operations on this. And similarly, we have promise in JavaScript. So that returns a resolve, and reject. So in resolve message, we can have string or numbers. So we can define that in the generic type promise. Now we can perform similarly this array functions, string functions in this string operations. Now, for example, we change this to number, then this gives an error. In resolve, we cannot pass, and we can pass some number here. Now this gives an error. The number we pass in resolve, and this operation that we cannot do now on number. So these are both are built-in. These are both built-in generic types that we can use. We can also create our own generic types for this.